In this video, we give you a quick overview of different methods for fine-tunings of large language models, or LLMs. LLMs are usually pre-trained using a large corpus of raw text data to obtain a base model. This way, the base model learns the trained language. But to use the LLM in a specific task such as text summarization, we need to fine-tune it using a related dataset to get a task-specific model. For this purpose, there are various fine-tuning methods. The most popular method is SFT, or Supervised Fine Tuning, in which we fine-tune the LLM using pairs of prompts along their responses. The other method is DPO, or Direct Preference Optimization. Another option is RLHF, or Reinforcement Learning from Human Feedback. The most recent option is ORPO, or Odds Ratio Preference Optimization, which we explain it in this video. The most popular method is SFT, in which we fine-tune the model using a data set of various inputs along with their responses. In a text summarization application, the input could be a text and the output could be the summarized version of the input. This slide shows the structure of a dataset that can be used by SFT for fine-tuning an LLM. DPO is another popular fine-tuning method that can allow us to fine-tune a model based on preference data. This allows the model to produce outputs that humans can prefer. To use DPO, we need a preference dataset in which for each prompt, we have a preferred response as well as a dispreferred response. This allows the model to learn the human preference from different examples provided in the dataset. The third approach is RLHF, which uses the concept of reinforcement learning to learn from human feedback. It uses reward signals from human evaluations to guide the learning process. RLHF requires a dataset in which for each input query, at least one response along with a feedback or reward signal is provided. The model then tries to maximize the total reward by producing better responses. As mentioned earlier, to use LLMs in practice, we first need to pre-train them using a large source of raw text. This gives us a base model. We can then use SFT to fine-tune it for a specific task such as question answering. This gives us an instruct model. But the instruct model usually doesn't produce responses that humans prefer, especially when building a chat model. To mitigate this issue, a preference alignment step is usually performed using DPO or RLHF by utilizing preference datasets. But if we use ORPO, we don't need to do these two stages. Instead, we can use ORPO to do preference alignment directly on the pre-trained base model. This way we can save a lot of training time and resources by doing the preference alignment in one stage rather than two stages. ORPO was proposed in this paper in 2024, and currently it is the latest fine-tuning method for LLMs. In ORPO, we add a new loss term to the SFT loss, which is a standard cross-entropy loss. Lambda is a control parameter, which controls the contribution of the new term in the loss function. The new term is called the odds ratio loss, which is defined by this formula. YW is preferred or chosen response in the input training data. YL is the rejected response. X is the input query in the input training data. We divide the odds of YW given X by the odds of YL given X. Also, sigma is the sigmoid function. The odds function is defined by this formula in which P of Y given X shows the likelihood of generating Y given X. Odds function equals K simply means that it is K times more likely for the model to generate Y than not generating it. Note that by minimizing this loss function, the odds ratio is maximized, which allows the model to generate more preferred responses. Another advantage of using ORPO with respect to DPO and RLHF is that in DPO and RLHF we need two separate models, one for the reference model and one for the policy network. But in ORPO, we only need to use one model for fine-tuning. This reduces the computational complexity of the fine-tuning process considerably. To use ORPO, we need a dataset in which for each prompt, a chosen response and a rejected response are provided. There are various datasets of this type. For example, you can use this dataset in Hugging Face to fine-tune your LLM using ORPO. Now let's see how we can use this dataset and fine-tune a simple LLM by the Autotrain tool in Hugging Face. To do so, you can use this command to start the fine-tuning process using Autotrain. You first need to use this flag to specify that you want to do training. In this example, we use Microsoft Phi 2 as our LLM. You then specify the path for the preference dataset that we just introduced. After that, you need to specify which columns of this dataset contain the chosen and rejected responses. You then specify the learning rate, the batch size, and the number of training epochs. You can now specify the fine-tuning model, which is ORPO. After this, you use PFD, which is an efficient method for fine-tuning. Finally, you need to specify your project name on Hugging Face along with your username and Hugging Face token so that your fine-tune model is pushed to this project on your Hugging Face project. By running this command, you can fine-tune your LLM using the chosen dataset. This was our quick overview of ORPO. Hope you liked it.